This is video on projectile motion. Here we are going to talk about problems of type 4. And when I say type 4, we have grouped the problems where somewhere along the line you need to work out the time of the flight. I think these figures will clarify it a little better what I'm trying to say. Type 1 we did was simple. Projectile starts from one level and ends on the same level. Type 2D we did was it starts from one level, goes to either level above or below, but in the problem the time of flight is not asked, and therefore we didn't require to work it out. But the type we are going to do now is projectile start from one level, go to some other level, either above or below the starting level, and we will need to work out the time. So you see, we can't fit these problems in the standard formulas, but we will have to go back to the basic kinematics equations, that is v is equal to u plus at, s is equal to ut plus half at square, and v square is equal to u square plus 2as. Let me take an example. Here is a problem which says a projectile P is fired at a muzzle velocity of 200 meters per second at an angle of elevation of 60 degrees. After some time, a missile M is fired at 2000 meters per second muzzle velocity and at an angle of elevation of 45 degrees from the same point to destroy the projectile P. What is asked is find height, horizontal distance, and time at which destruction take place. This is a typical example used in the war where you want to sort of knock down airplane, so you fire a missile. So those problems, the fundamentals used in this solution of this problem are used. Of course, we are neglecting air resistance, so to that extent, this is little theoretical. Okay, now let's look at this problem in a pictorial form. It says like this: that first projectile, projectile we have called it P, and missile we have called it M. They are fired as mentioned in the statement of the problem, and let's say they meet, that is destruction takes place at a point whose coordinates are xy. Now the main thing is what you mean by meeting is that point xy must satisfy equations of both the paths. That's the fundamental thing. So let's write out expression for x, thinking that it is for the projectile P. Then we'll write it for missile M. So for projectile P, if I see, x will be 200 cos 60 into Tp. Tp is the time. It takes to reach point x. Now same x for the missile will be 2000 cos 45 into Tm. If Tm is the time required to reach distance x for the missile. Now is the same x, so we as well equate these two, and if we do that, we get a relation between Tp and Tm. Let's keep it here, and then let's write equations for y, because for y I can write for projectile y is equal to, it is like s is equal to ut plus half at square, so it is y is equal to 200 sin 60 Tp minus half g Tp square, and for the missile it will be similar equation, but angle will be 45 time will be tm and initial velocity will be 2000. Now both y's are same, so we equate them. And since we have relation between Tp and Tm, we substitute for Tp Tm and we solve this. What we get is a numerical value of Tm, and that is 1.06 seconds. And once we know Tm, we can find Tp also. So we know Tp is 15 seconds. Now, x is easy to work out now. X is u cos alpha t for the projectile. So you work out x, either use u and t for the missile or for the projectile, and you will get in both cases same value, which will be 1500. And similarly for y, you can use either of the equations. I used for the projectile. So in this equation, 200 sin 60 Tp minus half g Tp square, I put value of Tp as 15 and I get my y. So what we have worked out is a location where the destruction will take place. X is 1500, y is 1494.4, and also the time, that is 15 seconds after the projectile is fired, the destruction will take place. Let's look at second problem. Here the statement is like this. A particle is projected upwards at an angle of 53 degree 8 minutes to the horizontal with a velocity of 100 meters per second. What time will elapse before it is moving upwards at an angle of 45 degree to the horizontal? See, as projectile moves ahead, the angle with the horizontal of that velocity keeps changing. So what they are asking, when this angle will be 45? Okay, how we do it is, the projection velocity of the projectile is 100 meter per second. Therefore, horizontal component is 100 cos the projection angle. That will be, if you work out the multiplication, it will be 60 ux 60. And one fundamental thing we have to remember, that horizontal components of the velocity of the projectile never changes. So even when the projectile reaches point xy where the angle is 45 degrees, still the x component of the velocity has to continue to be 60. Now uy, that is y component of initial velocity, is 100 sin 53 degree 8 minutes, that is 80, and y component of the velocity of the projectile when it is point xy is also 60. This comes because angle is 45 degree. The resultant velocity is a 45 degree. If x has value of 60, y has to have value of 60. Because after all, y by x has to be tan 45. Vy by vx should be tan 45. 1. So they are equal. So here is a situation, just look at the figure. Here is a situation where I know starting upward velocity of the projectile as 80. Then after some time, the velocity has become 60. So I can write v is equal to u plus 80 in vertical direction. Vy is equal to ui plus 80. Putting the numbers 60, 80 and minus a for a minus g, we can work out the time, and that comes to 2.01 seconds. It means the projectile which was inclined, the velocity which was inclined at 53 degree 8 minutes initially, will be inclined at 45 degree after 2.01 seconds, and this is what was asked. Let's look at third problem. It says an object is projected so that it just clears two obstacles, each 7.5 meter high, which are situated 50 meter from each other. If the time of passing between two obstacles is 2.5 seconds, calculate the complete range of projection and initial velocity of projection. Okay, here is how it looks. You don't know you don't know alpha. All you know, all you know is A and B are on the projectile path, and and distance between A and B, horizontal distance between A and B is 50 meters. So what we do, for point A, I can write the path equation. Y is equal to x tan alpha minus half gx square upon u square cos square alpha, where we can put y as 7.5. Again at B also I can write y as 7.5, but this time same equation, but this time x will be x plus 50. X will be x plus 50. Now we have one more equation, and that is, you see, if you agree that horizontal velocity of projectile, which is u cos alpha, never changes its value, then any distance x will be u cos alpha t. Now, now they are saying that this 50 distance between A and B is covered in 2.5 seconds. Therefore, I can write 50 is equal to u cos alpha into 2.5 seconds. The 2.5 is the time. And this gives me the third equation, u cos alpha is 20. Now, I can substitute this u cos alpha in 1 and 2. See, there is u square cos square alpha. So, it will be very convenient to substitute it there. So, if you substitute 3 in 1 and 2, then 1 and 2 is possible to solve, and we will get x and alpha. Now, where the problem is, on the distance on the left side is x, therefore distance on the right side also will be x. This comes from the symmetry of the problem, and therefore the total r, which will be 2x plus 50, will be 70.33. U and alpha can be solved, because alpha can be solved from first two, and then you can substitute in 3 and solve for u, and these are the answers you get. Only word of caution is, solving these equations is little long, is little tedious, but solutions are possible, and here are the answers. Thank you.